Okay. This work? Okay. Let's get going. If everyone could please come in and take their seat. We can declare HKG18 open. Everybody knows what HKG18 means. It's a pretty good acronym, I guess, of what we're doing. On behalf of the Linaro executive team and the leadership team, we'd like to welcome everyone here today and this week. As you probably know, a lot of effort goes into making sure this week is really extremely interesting, useful, fun, and we have quite an agenda set up for this week. And each Connect we learn and we think it gets better, and we get your feedback based on that, and it allows us to make it better. So there's a lot of good things going on this week, lots of good things. We were last here. Who was here last time we were in this hotel? Okay, quite a few, but some people not as well. And so we were actually here in February 2015, so it's been 3 years, and we're back. Really good location, easy to get to, of course, from your flight, assuming your flight comes into HKG. And we'll have a fun week, and we'll get to explore Hong Kong a little bit too. But let's get going. So first, we'd really like to thank our sponsors who have been really supportive and helped make this a great event. So for ARM, Fujitsu, Red Hat, and Hope Run, please join me in thanking our sponsors for sponsoring this event. We sincerely appreciate each one of their support. So George is going to kick us off in a few minutes, and you know George, he always comes up with cool new things, and he will bedazzle us, no doubt, this morning with some new stuff that we couldn't have even imagined before. And they've been hard at work at that, and that's always a great session. So in just a few minutes, I'll just give you a few notes about some of the things that are going on today and later this week. So a very popular meeting that over the last several Connects is AAA, Ask ARM Anything. So that's taking place at Grand Ballroom 1 starting at 10:30. So just so that you know, this is Grand Ballroom 2. Grand Ballroom 1 is over here. Grand Ballroom 3, which is also the TSC meeting room for the entire week, is over here. So pretty easy to get to. So if you're a member, because this is an NDA session, you can go to Grand Ballroom 1 at 10:30, and we'll have some really interesting questions. When we did this in Burlingame at the last Connect, the room was packed. It was standing room only. People were sitting on the floors. We've allowed for a little bit more room this time, so please join us and bring along your best questions. As I mentioned, the TSC meetings are going to be over here, starting at 11:30. So TSC, there's a week-long bunch of sessions, very important sessions, interesting sessions for the TSC. They kick off at 11:30 this morning and go throughout the whole week. There's a member services field kickoff meeting over here after Ask ARM Anything in Ballroom 1. So if you're in the Linaro field or member services or developer services teams, please come over here at 11:30. Afternoon sessions start at 2 o'clock, and at 5 o'clock there's an assignee and employee town hall meeting. In the past we've separated these into 2 meetings. We're going to bring the employees and the assignees together here in this room starting at 5 o'clock today. And then lunch has been expanded. It used to be run from like 1 to 2. Now it's going to start at noon and it's going to run to 2:30 every day. So it just gives you more time to spend some more time, and then when you can make it over to lunch, you can get over there. You don't have to rush to get over there exactly at 1 o'clock. We're using Pathable as our event utility and app. So you can go to the website, or you can search for Pathable Event Connect in your various app store and download the app and view it that way. And the work so far, the use so far has been pretty good with it. So Pathable is the way to see what your schedule is. And if you're new here and you haven't checked your schedule, it's a good, or if you've been here before, please do check your schedule, because we do sometimes insert meetings, important meetings during the week into your schedule. So like if you're an assignee, you would see that you would have an assignee meeting, an employee meeting today at 5 o'clock and so on. So please do check Pathable during the week. We did a data center day, if you remember, in Burlingame, which went really well in the middle of the week, where we bring in a bunch of outside vendors and companies that are involved in that ecosystem, and they talk about it, and it went extremely well. So we've expanded it this time around, and on Wednesday we're going to hold a special day that we're calling ARM Ecosystem Day. And Basically, there'll be 2 different tracks of vendors talking and engaging with us. There are no normal sessions, normal Connect sessions during the day on Wednesday. It's really focused on Ecosystem Day. So that should be really interesting. Robert Wolf, who holds these online 96 boards live sessions, open hour sessions live, he'll do it live here. He always concocts some new interesting device. So if you like 96 boards, please join the Open Hours live session, and he'll share with you some of his latest creative creations with 96 boards. And then, of course, Demo Friday will start at lunch, and at the end of Demo Friday, we'll close Connect Out for the week. So that's just some of the events that we have plans. We didn't have this last time, but Dave Piggott, who claims to be the smartest guy here, basically comes up with a puzzle, and it's up to us to prove that there are smarter people than Dave here. And so basically, there's a URL, it's a tiny URL, and if you don't want to write it down right now, you can take out your purple session guide, and the URL's in there as well. And the first person who solves the puzzle by the end of the week will win a special prize. So we always look forward to that. Linaro HR, if you're a Linaro person, even if you're not a Linaro person and you want to talk to somebody from Linaro HR, you can find Diane and her team in Office 2 on floor 2, so you can drop in for meetings and chat with her. And then we want to make sure that this week is really exceptional for everyone, that it's useful, it's interesting, you're engaged, you know what's going on. So if you have any comments, questions, you need anything, please see the great team that we have at the desk out front, because they're there to help and make sure that everyone has a great week this week. There are some socials planned for the week. So tonight is the employee assignee meeting, as we mentioned. The team dinners also happen tonight. There's another few dinners. If you need help, if you want to go out for dinner tonight, and you need help finding the right spot and making reservations, the registration desk can put you in contact with the right people here, and they're really good at this. Tomorrow night will be the committee evening, and if you've received an invitation, please accept it or decline it. All the committees go out together, and that will actually take place in the hotel. And then on Wednesday, there's a member services dinner. We also have wine and cheese night here, but also the team has set up bus service into TST, which is Simsashui. If you haven't been to TST before, it's like something out of Blade Runner. So you should definitely take a few minutes and go down to TST. There's a lot of fun down there. There's a lot of interesting stuff going on down there. I would really encourage you to check it out if you haven't been there before. And then Thursday is the gala dinner, as is our tradition. And so if you can come on Thursday night, we'd really love everyone to come. And everyone's been invited. So please go to the website and accept the invitation and just let us know that you'll be there. And I'll bug you some more about that this week. But please let us know so that we can plan for the right number of people. And then we talked about demo showcase in Grand Ballroom 3 on Friday. Okay? So pretty good week in front of us, lots going on. If you need help, talk to us, and we'll figure it out. And I'd like to, one more thing. So as is also our tradition, right after this meeting, we're going to go out into the hallway here and do a group photo of everyone together, and that will serve for the record going forward of our group photo. We did one when we were here last time. We did one in Burlingame. It's really a fun thing. We like to do it and get out of the way. So as soon as George is done, please file out into the atrium out here on this floor. We'll take a group photo, and if you're a committee member, please hang and stay there after the group photo, because we'd like to take a group photo of all the committee members there as well. Okay? And then all the sessions will get started directly after that. So thanks very much, and please join me in welcoming George Gray, CEO of Linaro.
Okay, good morning, everybody. Thanks very much for coming. I know some of you are going to have found it difficult waking up this morning, and some of you will have been awake for many hours, but either way, thank you very much for coming. We've got a lot to cover, so I'm going to get started straight away. I'm really pleased to announce publicly that China Electronics Corporation, CEC, are joining Linaro as a top-tier core member. Thank you. So CEC, for those who don't know, are a major Chinese IT supplier. They deliver globally, and it comprises a consortium of over 100 companies, of which at least 14 are listed, and combined they have over 130,000 employees worldwide. So we're looking forward very much to working with them and to their contributions to the open source community. Thank you again. I'd also like to welcome a couple of new members. Cyprus are joining Linaro as a light member. They're particularly interested in working with us on the Zephyr project, which we'll talk about in a moment. And Rockchip have been appointed to the 96 Board Steering Committee. You'll hear a little bit more about some Rockchip products later. And finally, Runtime.io have joined the Light Group as an associate. Again, they're interested in our work in the IoT space. We look forward to working with them. Okay, so it's always difficult for me to single out any engineering highlights. For those of you who know Linaro, those of you who are members, which is most in the room, you get every month a list of a fairly long document of all of the engineering accomplishments of the month. But I'll just pick out a few. One is obviously in the area of Linux and the kernel. There's been a lot of work around security over the last 6 months. There's been a lot of work on OPTE, which is the drivers are now in the upstream kernel. And OPTE is getting new secure applications for secure data path, trusted applications. And I'd also like to mention Nico Petre's work on IOTL, or Tiny Linux as it's called in Linaro, which is work upstream to make sure that you can actually build from upstream Linux a small implementation suitable for an embedded device, whether with an MMU or without. So if you're interested in that space, I encourage you to look at his work. Open Data Plane has been a major project for LNG over the last few years. I'm very pleased that today we're announcing the release, the forthcoming release of the Tiger Moth version, which will be the first LTS release for Open Data Plane. That will be available later this month, and there are sessions on it this week, I believe, in room 106 later today, if you're interested in Open Data Plane. There's also work going on in LEG around DPDK in order to actually get the Open Data Plane APIs available in DPDK. Finally, I want to mention the Developer Cloud. A lot of work has been going on behind the scenes on the Developer Cloud. And if you want access to ARM servers for developing, testing purposes, check out linaro.cloud, register, and we can make available instances for you either in Asia or in the US or in Europe. And all of our software, as usual, is available on linaro.org/downloads. Okay, Zephyr. So Zephyr project was started in Light a couple of years ago. Zephyr is a open governance RTOS. The goal is to kind of be the Linux of RTOSes. And the question that we've always asked, and you're always asked in a new open source project, is when are people actually going to use this? So I'm very pleased to announce that one of our members, SaneChips, which is the subsidiary of ZTE that builds SOCs, has recently launched the Rosefinch 7100 NB-IoT chip. This device is a mainstream product for NB-IoT wireless modules globally. It's already got a lot of design wins. And inside it has 3 cores, one of which is running the networking stack, and that is running Zephyr. It's a production use of Zephyr in a mainstream SoC chip. So we're very pleased to see that. But it's not only our members. Products are starting to appear in the market that are using Zephyr as a key part of their technology. So the Rigado Gateway, for example, has Bluetooth technology running on Nordic chips, and the really interesting thing about that stack is it's completely open. Normally, historically, when we've used a Bluetooth chip, It's been closed, you haven't been able to see what's going on, and more importantly, you haven't been able to easily fix bugs. That's now changed, and products are starting to appear using the Zephyr Bluetooth stack, which is completely open and also supports BLE mesh. Recently, also, a complete open thread implementation has been announced for 802.15.4. Other projects that are actually shipping today include a wearable wrist device, an intelligent glove for use on a factory floor, modular watches, intelligent shoes, and intelligent toothbrushes. So this is just the start. I was at Embedded World a couple of weeks ago, and there was a team at ELC last week, and we're seeing real momentum developing behind the Zephyr project. If you're interested in RTOSes, please contribute. So for those of you who are not completely familiar with Linaro, we're a unique company where competitors in the ARM ecosystem can collaborate together on open source projects that benefit all of us. And there are a number of projects that obviously we're involved in and known for. We're a major contributor to the Linux kernel. The OPTE project is an open source trusted execution environment that is able to be global platform certified, and I've already mentioned Zephyr. We're also working with ARM on trusted firmware. For those of you who are interested in trusted firmware and security in firmware, please attend those sessions this week. They're going to be very interesting. And there are a number of platform activities that we're getting more and more involved in. So data center, containers, fog and edge, AI, and automotive. And I'm going to talk a little bit about some of those later in my presentation. So we now work across a very large number of open source projects. We have over 300 engineers globally working on over 70 open source projects, of which this and these up on the screen are just a selection. Okay, so I showed this slide the last time, and I'll probably show it every single conference from now on, because one of our challenges in open source is balancing the needs of building and maintaining open source for today's projects and looking at the future. And in order to go through the process of architecting and delivering new technology for new IP, we need to be working on software earlier and earlier. And so we have to work out what is the industry going to be by the time this new software effort gets actually into products. And I submit to you that our world is changing very rapidly. It's going to affect everybody in this room and everybody outside this room. There is an unprecedented level of connectivity going on in the world. There is increasing product complexity. If you start looking at some of these, we thought Bluetooth was a relatively complex project. It's getting a lot more complex with meshes, with new technology, longer range, more security. Look at 5G, going to be very, very complex. And data is everywhere. We're creating crazy amounts of data. Terabytes of data from cameras, audio devices. This data is sitting in devices, it's going to be on the edge and in the fog, and it's going to obviously be processed in the cloud. And there are two real drivers of why things are changing. One is 5G. 5G is going to make 4G look slow. But it's also going to enable low bandwidth devices in the millions or even billions to sit on the same network and transmit small amounts of data occasionally. And this is going to, again, change everything. And security is becoming a major concern to everybody in our industry. If you are building a product and you're not taking account security because you don't have time, because you've got to get the product to market quickly, and it's connected, you're making a big mistake. So I want to talk a little bit about how we build products with Linux today. The last stable Linux kernel, which is the most recent stable kernel, which is the best kernel because it's got the most fixes in it, it's got the latest security patches in it, it's got latest hardware support in it, was released 4 days ago. So it's pretty tough to get software that's 4 days old into products. The most recent long-term stable kernel was 4.14, which was released for the first time in November 2017. SOC vendors, particularly in the embedded space, have tended to provide board support packages that is the combination of the kernel and their own code. And a couple of SOCs that we regularly work with, and I deliberately didn't pick the oldest here because I didn't think it would be fair. A number of the companies we work with use the 4.4 LTS, which was first released over 2 years ago. And a number actually go with 3.18, which was released over 3 years ago. And the oldest LTS kernel that's currently supported is over 6 years old. Now just think about that for a minute. We're supporting and building software that's 6 years old. We're putting that into products that may last 10 years. So by the time we finish, we're coping with maintaining 15-year-old software. But that's okay. It's long-term supported, so it's all right. I don't think it is. And I want to explain why. So firstly, security is changing everything. We need security because we're connecting everything. And proprietary security as the core platform for building products is not a good idea. Because if you build proprietary security into your product at the lowest level, then it's going to be very difficult to sell your product outside your local region. So if you build special security for China, you can't sell it into the US. If it's coming from the US and you don't know what's inside it, you won't use it in China. So open source has to be the way forward for the core platform, and then you can build whatever you need that's proprietary on top of it. So what about security in Linux? Well, the latest kernel software, the upstream, is where the latest security fixes are first put. Has the latest security patches, it gets those patches before any other Linux release, and it supports the most hardware. And then what we do is we backport those key patches for security into the long-term supported kernels. The older the kernel, the harder that becomes, because some of those patches may depend on features that weren't available in the kernel when that kernel was first produced 6 years ago in our worst-case example. That means they take quite a long time, potentially, to actually be engineered in. And by the way, they don't get tested as well either, because not many people are using or updating products in the field that are based on those kernels. So the best software, the most secure software, is the latest software. So how do we actually use this in real life? Well, we start with an SOC board support kernel. Let's say it's 3.18, so we're 3 years old already. Then we get some SOC vendor code, and that includes probably some binaries for things like radios or GPU stacks or video, whatever it is. And then often we start by using a development board. And pretty much a lot of the time, that's not actually from the SOC vendor itself. It's from a third party who's chosen different peripheral chips that need to be also supported that may have their own binary blobs. Meantime, the clock is ticking on our product development. Of course, because it's my product and I've done some special things in it, I need to make my own kernel changes as well to that 3-4-year-old software by now. So we better put some patches in because LTS has moved on. So we've now, as part of the engineering activity, it may take a year or two to develop our product, we've actually got to monitor LTS patches and make sure all those come in too. And then the SOC vendor, they didn't quite get their blobs right, or they've put new functionality into them, or there's more security that they need to put in. So they're sending some more patches to us as well. And does all of this always work first time? No. There are conflicts. You have to resolve them. Your engineering team has to fix them. And then we have to create our final kernel product. And we have to test it in our real product. And that's going to find problems as well. By the time you've finished all of this, you're done. You've got a real kernel. It's a bit of a melting pot. And I would argue that your final tested product kernel is a snowflake. It's a snowflake because no two are the same. You've created a unique product. So it's not Linux, it's based on Linux. And 3.18, our original start, is about 150,000 patches, I think I'm being conservative here, behind upstream. That's a lot of changes. It's a lot of new hardware support. It's a lot of new everything. And you can expect typically to see between 100,000 and in some cases over 1 million lines of vendor code in that product that hasn't been through the open source process. The result is something that's completely custom for your product. And you may be supporting that or paying for the support of that in an industrial or an automotive product for over 10 years. Just think about the cost of doing that. It's a huge maintenance cost. Doesn't matter that it's based on an LTS kernel. It's yours. Nobody else knows how you built it. It's very, very expensive. And now a new security flaw comes in. It's urgent for you to fix it. You've got a lot of work to do. The older the product, the harder this becomes. Here's a not uncommon example. This is a car, 2017 model, from a major manufacturer, and the IVI system, which connects to the internet through Bluetooth, is based on kernel version 3.1.10, which is 6 years old. That car is going to be driving for another 10 years. That software is a completely customized software build. That is not uncommon. This is how we do things. And I argue that we can and must do better. And I question whether LTS is actually still the best approach, given the challenges that we face in our industry today. If the best software is the latest software, why can't we use it? Those ARM vendors who are working in the enterprise space have come to realize they have to support upstream on their SOCs, or nobody will buy them and put them into their data centers. For this very reason, they need to keep up to date with new distribution versions. They can use the best software because they've designed their architecture and their systems around standards that enable them to do it. So if the best software is the latest software, why can't we use it in embedded products? The development cycle is too long, we're told. Surely it's easier to develop an embedded product than it is to develop a server. Certification and compliance takes a long time. We can't change the software. The risk of making changes during our engineering cycle is far too high, delays our product launch, and anyway, our process doesn't allow it. And actually, to be honest, unless it's an enterprise SOC, we're not giving those product developers the option. Very few embedded SOCs are properly supported upstream. That is changing. It has to change. So how could we solve this? How could we start with the latest upstream software? And how could we design to be able to continuously update that through the product lifetime? We have to get a lot better at continuous integration and use case testing with our own use cases for our own products and regression testing as we continue to evolve. Other companies do manage to do this. There are a small number of vertically integrated companies who are very good at delivering the latest updates, new security patches, new functionality to our devices on a regular basis, to millions and millions of devices. The benefit of doing this, if you can manage it, is you get those security updates, you get those bug fixes, you get those new features, and you can deliver much more secure products at a much lower cost. So what would we need to do? First, we need to support new SOCs upstream. This becomes an imperative. We have to improve our CI testing. So kernelci.org that Linaro has been involved with some other companies, is a good start. But it basically only tests that you can boot each kernel on each check-in. We need to do proper functional CI testing. We need to build better and better functional and regression tests that apply to all of the software that we develop. And most importantly, we have to do that upstream because nothing else scales. Testing just your own version doesn't actually help everybody else. And as a result, you don't get the benefit of everybody else's testing. But if we're all working upstream on the same body of code and we're building our products around the same foundation of code, closer to upstream, then it scales. All the testing that everybody's doing is making the whole thing better. That's what happens in the enterprise space. And we have to develop much better technology so that we can test in minutes with every check-in, not in hours or days. So my plea to SOC vendors is this. I get that you need to get your product out. We all do need to. That's part of business. Our teams, our engineering teams, are working very hard on the next generation product, every generation. And this is not going to change, not at least overnight. So every vendor, in addition to doing things the way they're doing them today in the embedded space, particularly those who are working on products that are targeted at industrial markets, automotive markets, AI, products that are going to last a long time, you need an upstream focused team. You need a team that's working on getting those pieces of technology, those SOCs that you're going to support for a long time, upstream. Because only then are we going to be able to fix this. Linaro is here to help. In the enterprise space, we build these reference development builds, which are a kind of staging place for all of the vendors to make sure there are no conflicts before that technology is delivered upstream. And the mainstream distributions are using that as the basis to get changes into their own products. We should consider how we do that in the embedded distributions. And the Linaro Developer Services team and landing teams are here to help you train your engineers. But you really do need to set a separate team up for this because they've got to be off the critical product delivery path for you. So that is my plea and my proposal today. Okay, so I'd like to change tack here. I said that Linaro works on a large number of projects, over 70 open source projects. That happens day to day. We have an extremely talented team of our own engineers and our members' engineers working on these projects every day. And those are driven by our members. The members choose which projects. But we also have a responsibility to get ready for that puck. We have a responsibility to help the ecosystem develop. We have a responsibility to try to avoid fragmentation because of the nature of the ARM ecosystem before it happens, not try and clear it up afterwards. It's a lot harder, it's a lot more expensive. And there are two particular areas that have got a lot of attention over the past year. One is machine intelligence, and the other is autonomous vehicles. And I want to talk a little bit about both of those. So let's start with machine intelligence. We're in a very early market adoption phase, driven by mobile, interestingly enough. The major AI machine learning software technologies are largely open source. They're very big projects. Machine learning done on cloud-based servers, and then the inference, the actual using of those models and training is going down to smaller and smaller devices. Mobile phones today, but it's going to go further. It's going to go down to microcontrollers. Everybody's trying to create better and better algorithms and hardware. So everybody's creating their own hardware IP. And that's their business model. They want to monetize that IP. Those typically are going to be proprietary. We can't avoid that. Now, there may be some very advanced people who actually take a different view of the world. And I particularly call out Nordic and what I said earlier about Bluetooth here, in that they're actually using Bluetooth stacks that are completely open source and seeing more adoption by the early community here because we can actually help fix the bugs as they come up. And that project is getting more and more complex if you look at what the Bluetooth committees are doing. So maybe somebody will actually produce fully open IP and AI ML hardware. But I think in general, we have to recognize that this is kind of GPU again, but there's going to be a lot more of it. So we need to create platforms that enable developers to actually use and build machine learning software, use the hardware in everything from the data center to edge, fog devices, and endpoints. And we need to be able to deliver high performance and low power, right? So we in Linaro are starting a machine intelligence project. And the goal of this project is to provide best-in-class deep learning performance by leveraging neural network acceleration in hardware IP and SoCs from the ARM ecosystem, by collaborating on the most widely adopted AI ML software frameworks and libraries. So this is things like TensorFlow and Caffe and Torch and many others that are going to appear that tend to be open source. But they also tend to be developed only for one or two platforms. So if you look at TensorFlow today, works on CPUs, works on CUDA, and then some people have tried to get it working using OpenCL, which isn't the ideal for actually what we're doing here. So the problem we have is that we've got a whole bunch of frameworks that are using different descriptions of way to create models. We've got a whole lot of different hardware IP, and anybody who wants to create hardware IP has to go and try and get support and hack every one of those AI frameworks in order to get them to work efficiently on its own hardware. The other side, the frameworks, don't have the resources to go and build software for everybody's proprietary IP, even if they could see it, which they can't. So we need to basically agree as an industry an interchange format between the different machine learning frameworks and libraries and the hardware IP. And there have been some initial attempts to do that. But one of the key things that Linaro is going to try and do in conjunction with the ARM ecosystem is to actually solve this problem and agree what that interchange format should look like. And this work has been initiated and invested in by some of our core members, and we invite other members who are interested in this project to join us. In order to actually do this, we need to do something pretty unusual in our industry. New technology is usually kept behind closed doors, particularly in the ARM ecosystem. But it's kind of hard to do this work unless we've got access to new technology. And 96 boards was intended not as a platform for very low-cost education, but as a way of getting the latest mobile technology and then extended into enterprise and IoT to developers. I'm very pleased that in the 96 boards program, the Dragon board is now finally available. This is based on a new embedded version of the Snapdragon 820 that is getting long-term support from Qualcomm and builds on the success of the Dragon board 410 and has a range of additional devices. It follows the extended format, including support for mini PCIe cards and for gigabit Ethernet. What's interesting about this chip is it's going to be around for a long time, and it's got multiple CPU elements. It's got a CPU, it's got GPU, and it's got a DSP in it. And that gives you the ability to do heterogeneous processing, putting the right load onto the right core. Those boards are now shipping to developers, and Linux support is going to follow for that heterogeneous processing later in the year. And they plan to support 96boards.ai. What is 96boards.ai? I'm very pleased to announce today, here, 96boards.ai, which is designed as a program to get hardware to developers who are interested in working on machine learning and machine intelligence today. So I want to talk a little bit about some of the things that we've been doing. Firstly, when we came to the last Connect, we showed off a very interesting project from SocioNext, which was the Synquesa SC2A11 part for enterprise. The part is a 24-core A53. Those cores are running at 1 gigahertz. The interesting thing about this part is one of those only uses 5 watts going at full power. That's available on the 96 boards enterprise card. A lot of work's been going on since we showed the prototypes 6 months ago. And that card can now actually boot upstream kernels. It has open source firmware and can boot upstream distributions out of the box. A lot of hard work's gone on in SocioNext and in Linaro to make that happen. And it's an example of a reference that now ARM developers can use to build ARM with ARM. That board has up to 64 gigs of RAM. SATA Gigabit Ethernet is available as a 96 boards Enterprise Edition or in a package system. And SocioNext and JarFalcon have teamed up to work with some technology that JarFalcon introduced at CES earlier this year, just a couple of months ago, and they created quite an impression. They have created an AI/ML neural compute processor that has 28,000 cores on each chip and that processes 9.3 teraops per watt. And they've put 8 of those onto a PCIe card, and there's one of those sitting in there. So this is a really interesting platform for people to actually play with. So I want to show you what it can do. This is still a work in progress, but this camera, which is showing here, is showing the power consumption of this box. So it's using 32 watts. That's about an 80% power efficiency on the power supply, so it's actually using about 28 watts. Yes, I said the chip only uses 5, but there's memory, there's graphics cards, there's a whole bunch of stuff in there. There's disks. So that's what it's using, 28 watts, and it's pretty idle. If I show you the screen, this is actually connected to the box, so if I sit down to be comfortable, uname -A. So this is actually running 414, and if I do PS, X, so we've got a lot of processes running, so that's all. And you can see on the right-hand side here, you can see that most of the processors, or you probably can't, but it's pretty much 0% processor usage across the entire 24 cores. And we're still using 32 watts. So what we're now going to do is show a demonstration of object recognition on multiple simultaneous video streams. So can we go to the other? Yeah. So this is just starting all the video streams. Next. Can we switch over? So next, I'd like to make another announcement. This is based on the Kirin 970 chip, which is Huawei's first mobile AI computing platform. It's what has gone into their latest phones. And it includes a NP, a neural processor. For the first, this chip was only made available in phones at the end of last year. It's pretty incredible that only 4 months later, we're going to be delivering a development board built by HiSilicon to be able to actually access this and use it for software development. So I'm very pleased to announce that the first edge AI computing platform with NPU capability, the HiKey 970, is going to be available very shortly. I actually have one here. It's an extended CE format board. And this has the 970 chip on it. It has PCIe, it has gigabit Ethernet. It also comes with the High AI SDK, which I'll talk about in a moment, but it's delivering 25 times the performance of CPUs with 50 times power efficiency for doing machine learning applications. It has a dedicated NNP and has heterogeneous resource management. And the SDK, which is available today on GitHub, provides AI compute libraries and APIs, enabling developers to easily and effectively develop new applications. It does interface to TensorFlow Lite and to TensorFlow and Caffe. And it enables you to use selectively the CPU, GPU, DSP, and NPU. It comes with toolchains, documentation, a rich set of APIs, and easy-to-use source code. And it's not even the first version. The second version is now out that supports more operators, more frameworks, better tooling, more documentation and support. As I said, you can get all this on GitHub today. So the HiKey 970 enables new products in industry, audio devices, video devices, robotics, automotive, and we can't wait to see what people actually do with this product. Okay, that's not all. Next, new member of Linaro, Xilinx, has a very interesting chip that is now available on a 96 boards CE footprint. There's one running here, and we're going to show you that in a moment. So the Ultra 96 is a unique product that's been built using Xilinx's FPGA technology. I think most of us know, but for those who don't, FPGAs have been around since the 80s, which actually isn't that long ago. They were initially used for glue logic, so you didn't have to have lots of little individual integrated circuits. You could just put an FPGA in. But Moore's law applies, and more functionality has been put into FPGAs, and the process has improved dramatically. And today's FPGAs actually rival Intel processors in terms of the number of transistors and complexity. You can get FPGAs with more than 1 million gates in them. And a few years ago, Xilinx revolutionized the FPGA space by adding embedded processors into the SoC. Initially, they started with PowerPC, and then they saw the light and they started working with ARM. The first FPGA with an ARM processor used the Cortex-A9, and that product's still available in production and widely used. But this product features the latest generation of the Zinc technology, which is called the UltraScale Plus FPGA. And this has an embedded quad-core A53, has 2 Cortex R5 real-time processors, and a Mali GPU, and a fabric acceleration block, which is the FPGA. And that's what really makes it different. This acceleration block can be programmed to do virtually anything a processor can do, but almost always faster because the function is actually done in hardware, gates and logic, rather than compiled or interpreted code. So we're going to show a demo which is going to show a small neural net function implemented in that FPGA. And this is a relatively simple application of the FPGA logic, which of course you can reprogram for many other purposes. So what we're going to do is demonstrate a quantized neural net implementation of tiny YOLO, and this work was done by Xilinx Labs in Dublin. So quantized neural nets are interesting because when they're properly trained, you can get a much smaller implementation, especially for an FPGA. So if you only need, say, a 3-bit coefficient, so not 8 or 16, but you can do it in 3, you only need to implement as much logic's needed for the 3-bit numbers. And fewer bits means lower power. You can't really do that with a CPU or a GPU because everything's fixed in hardware. So what Xilinx has found is that reduced precision works fine for neural networks that are used for object classification. And this demo leverages this fact to reduce the computational footprint of the network such that high performance and low power can be achieved. And the demo consumes on the board about 6 watts, which is actually pretty impressive for an FPGA-based design. So what we're going to do is we're going to take a live USB camera feed, which is pointing in this general direction, and use the neural net accelerator in the FPGA fabric in real time, and then show you the results of that analysis. So what this is doing is actually training a bunch of different object classes, and it will try and recognize those objects in the video stream. Unfortunately, it wasn't practical to bring some of the objects that they've trained it on into this room. We couldn't find an aeroplane or a boat or a bus, so we're trying with a few people. Okay. So the charts at the bottom of this slide show the performance and how the hardware versus software parts of the implementation work. So on these graphs, software is on the top and hardware is on the bottom. So the first and last stages of the algorithm are actually software executed on the CPU complex. And the rest of the implementation, which was in the pink box on the previous slide, this one, is done in the FPGA logic. Okay, so the graph on the far left shows that even though software only executes the first and last stages, it actually took 4 times as long to execute that in this demo than the hardware, the pipe stages that are going on in the FPGA. The graph in the middle shows how many millions of operations, or MOPs, were actually performed in the hardware accelerator, most of them, and on the ARM cores, not very many. And the FPGA is implementing orders of magnitude more MOPs than the software. So the FPGA doesn't have to execute and fetch instructions, and hence it's much faster. The right-hand graph shows the actual performance measured in gigaops, achieved in the measured inference execution, and it's basically the multiplication of the previous 2 numbers. So let's look at it first on a single object. So the object, the picture is on the left, and the 20 object classes, Pascal visual object classes, are live classified and indicated through bounding boxes, and you can see it identified a car, a dog, and a bicycle. And this shows a single frame. But since the whole pipeline, which we looked at the previous slide, can run in real time, we can actually stream images together to make a video. So that's what we're going to do. So what we should see on this one is can we see the picture of the board? So here's the board. Can I focus it, or does it just, maybe if I, yep, there we go. So this is the Xilinx UltraScale board, and it's connected to a keyboard and mouse and to the camera, which is pointing at the gentleman in the front. So I'm now going to ask the gentleman at the front, please, and lady, to stand up and walk a little bit towards us. And what we should see, yes, that's started, is as they walk and mill around, you see it starting to recognize them, and that is how this works. So if you guys would like to go and take your seats again. I do think some of the gold chairs is not something that's usually been trained on, which is why it doesn't seem to be recognizing everybody at the moment. But you get the idea. This is a pretty amazing piece of technology for something that's this big, a 96 board that you can program with your own algorithms and your own ideas for how to actually do object recognition and anything else in AI and machine learning. So we're pretty excited about this. And the board itself is going to be available from Avnet. Orders go up today. If you go to 96boards.ai, then you can actually navigate your way to finding and placing a pre-order for the board. Should be delivered within 6 weeks from Avnet. And the price is $249 with 2 gigabytes of RAM.
I'll take 5. I have my credit card right here.
Sold to the man in the front. Okay, good. So one last thing. I mentioned Rockchip at the beginning. We're very pleased to have them joining the 96 Board Steering Committee. And I'd like to introduce today the Rock 960, which is an AI-ready platform designed and built by VAMers, who are a 96 Boards manufacturing partner and who work with Rockchip technology. The Rock 960, which is available today, and they've used a very interesting URL, I wish we'd got it, which is 96rocks.com. The version today uses the current RK3399 CPU, which does not include an NPU. That board is $99, and you can get it today. What we're announcing here is that Rockchip's new version of that chip includes a dedicated NPU that operates up to 2.4 TOPS. And it also includes 2 Cortex A72s, quad-core A53, a relatively recent Mali, and up to 4 gigs of RAM, high-speed interfaces including USB 3 and mini PCIe. This board will be available with the NPU later in the second quarter, and we expect it to be aggressively priced with software. We expect this to be a very interesting product. They've not only done that on the CE format, but they've also produced an Enterprise Edition board. This has the same processor on with up to 8 gigabytes of RAM and adds full-size PCIe 2.1 slot and dual SATA interfaces, gigabit Ethernet. And this also is capable of remote management, either by 4G LTE or a dedicated management port. This would make a fantastic edge fog device for a lot of applications. So we're really interested to see what developers do with this. So that's Rockchip. Rockchip have actually partnered with OpenAI Lab. OpenAI Lab are a team working here. They've been working with ARM and others, and they provide the OpenAI development platform, which is an open source platform on the Rock 960 products. And this simplifies the application and development of vision and speech on the edge, domain libraries for vision and speech inference, unified APIs, works with deep learning frameworks including Caffe, MXNet, and TensorFlow, and uses a heterogeneous computing library which is built on top of ARM's compute library, which has been optimized so that you can use ARM CPU and GPU and then the NP. This is a perfect example of why this is hard at the moment. We need to basically make it easy to take all of these different AI and machine learning engines and actually connect them effectively and efficiently to TensorFlow, Caffe, and so on. So Linaro is going to be talking with Google, with Facebook, and with others to work and seeing how we can get together to make this more efficient for the entire ecosystem. On my left, and I'm not going to show you it today, they didn't trust me with it, is a new industry-oriented business robot. There's a range of these products, And you will be able to see this demonstrated on Ecosystem Day on Wednesday, and then again at Demo Day on Friday. And this product is one of the first that's going to use the Rockchip 960. A version of this product will use the Rock 960 boards. So these boards are starting to appear in real products. So in summary, 96boards.ai is delivering a number of different boards that can be used today with open source software supporting major operating systems, including Android NN and including Linux. And you can start working on these boards today, and they will help us develop this ecosystem far faster than we can do any other way. So the SocioNext board, the HiKey board, the Xilinx board, the Rock 960 boards, and Qualcomm are also joining and planning to join the program at the end of the year with the Dragon Board 820. Thank you to everybody who's worked so hard in making this happen. Okay, so just before I let you go and have our photograph taken, I'm going to talk very briefly about what we're doing on automotive. So Linaro is also starting a project on autonomous vehicles. That's obviously slightly linked with the last topic. But the goal here is to accelerate the ARM ecosystem in autonomous vehicle control by defining, adopting, improving, and promoting open source software platforms and a scalable architecture suitable for cars, other vehicles, buses, taxis, robotics, and drones. This is a real challenge because this is really one where we do have to look ahead. The next few years of cars are done. Plans are done. So if we want to get into a design cycle with open source software, and most of the car vendors are looking at using open source software in various parts of their projects, we've got to actually look at where we're going to be in the next decade, where we're going to be from 2020 to 2030. And my assertion is that the kind of fully automated cars without steering wheels, level 5, where there's no attention being paid by the driver, or not the driver in this case, is going to be based on a very big SoC that's going to do everything. What's that SoC going to look like? It's going to have a compute complex. That compute complex is going to be doing all of the kind of things that we've just been discussing. It's going to have a sensor fusion complex, which is taking the gigabytes and terabytes of data coming from the cameras, the radar, the ultrasonics, and every other sensor in the car, and is going to be mapping the world around us. It's going to have a bunch of peripheral interfaces for the UI so that we can watch Netflix, and have storage locally, a bit like a black box in an airplane, and is also going to have networking capability because a lot of the data we're going to either be getting into the car or we're going to be talking to other cars or other objects around us or sending up to the cloud. And most importantly, for us and our families, it's going to have a bunch of safety and control technology in it to make sure that when something goes wrong with the compute complex and it gets a silly command, it doesn't immediately jam the brakes on and hurt us all. And it also hopefully keeps out of the way of everything else. That kind of technology has really only historically been needed in other vehicles where humans actually don't have any control. So let's think of something like the space shuttle, right? The astronauts really couldn't do very much. They're strapped in, and it's going rather fast. It's a fully autonomous vehicle. How did they solve the problem? They had 3 or 4 computers all doing the same thing, and they voted on which, if one of them said something different, they basically said that data's not valid. That sort of thing is going to happen in automotive as well. So today, there are probably only 2 companies who make available early versions of this kind of technology. And if that goes on much longer, we're going to end up in a monopoly or duopoly situation, which turns out to be very expensive, very proprietary, and I think everybody in this room would agree not the best way of doing it. We can really make a difference using open source for developing this and accelerating the development of these machines. And we need it to be open source because we need everybody to be able to see what's going on and make it better and find the problems. So we need to identify key open source technologies for autonomous software. We need to involve the manufacturers and the tier 1 and tier 2 vendors in the supply chain. We need to build working proof of concepts on commodity hardware. We can't all go and buy a $100,000 or $200,000 automated car to start experimenting. We're going to need boards, we're going to need software, we're going to need simulators, we're going to need real cars. And we're going to need to iterate. We're not going to get this right first time. So we've got to have an architecture that's flexible enough to iterate as we move forward with different components and new technologies as they appear. And this is an opportunity for everybody in the ARM ecosystem. We also need to enable substitution of any pieces of this architecture with proprietary technologies where they're more appropriate or customers actually want to provide them into the market and monetize them. So what might a platform look like? So at the bottom, it's going to have some very secure and trusted firmware. There's going to be some kind of microkernel level 1 hypervisor sitting underneath everything, bare metal, as close as possible. And on top of that, that is going to be certified software. And on top of that is going to be a certified safety RTOS that's running the safety system. On the other side is probably going to be some kind of minimal Linux implementation that's completely secure and completely over-the-air updatable. So all of this software has to be updatable. And then we believe that a bunch of containers is going to sit on top of that, and those containers is where we're going to develop IVI, level 5 autonomy, sensor fusion, the AI/ML software, and so on. So one of the things that a special interest group in the Technical Steering Committee in Linaro has been looking at over the past months is, where do we start? What are the kind of components? What should this architecture look like? And there are a number of companies that we are looking at. We would welcome everybody's input into this. And some of these companies are here this week. So Kern Concept are here. They came to the last Connect as well, talking to us about the L4RE microkernel. There's a new Linux Foundation project called Acorn that we need to look at. Zephyr is moving to be certifiable. So that means that MISRA and ultimately ISO 262626, too many, will also be possible using Zephyr in the future. And looking at micro platforms from companies like Open Source Foundries. Recently, last week, they demonstrated a full Optane and TUF compliant methodology for over-the-air updates of Linux. This uses the same kind of technology as CoreOS. It uses capsules. It uses OS tree. And Optane is actually being designed for security, and it's been threat modeled to be a secure platform for automotive applications. It was originally funded by the US Department of Homeland Security. And TUF is the update framework. You can do your web searches for getting more information on that. We also have AGL here this week. AGL have made a lot of progress over the last few years and are delivering in production cars software, particularly for the IVI system and some of the ADAS functionality. OSRF are particularly interesting because of the ROS 2.0 software for autopilot kind of applications, and they also have simulation technology. And the PX4 Autopilot is the industry standard open source software for drones. It's also applicable in a lot of ways to the two-dimensional car implementation. There are a couple of high-level autonomous driving open source projects. One is Tier 4, which is a Japanese company. A lot of interest in their project that was started up in academia, which is called AutoWare. And Baidu have started in China a project called Apollo. And lastly, in the UK, there's a startup called Street Drone who are building a fully autonomous EV, electric vehicle, based on the Renault Twizy that can be used as a relatively low-cost way of actually trying out these kind of platforms on a real car. So this, at the moment, is an evaluation stage. We are building a team in Linaro to focus on this and work with you all and work with others in this industry to try and move this forward and to encourage the total involvement of the ARM ecosystem. We're pretty excited about the opportunity of this for growth in the future. So it only remains for me to say thank you very much for coming, listening to me for so long. Please use this opportunity this week to collaborate. You are here not just to learn, but to work with each other. Open source is about a community and working together. And please, above everything else, enjoy your week here. Thank you very much. You done?
Does this work? Okay. So if everybody could just kind of file out into the atrium area.